Okay, the essential question is how can you graph a linear inequality in two variables? And we looked last time that this is very similar to graphing an equation. There was just a few differences. And so looking really quick, when you graph an inequality, one of the differences is when you have the answer, you have to either use a dashed or jagged line, or you can use a solid line. So that's one of the differences. Well, let's go ahead and answer this question with an example. And do take notes on this. So it says to graph this negative x plus 2y is greater than 2 in a coordinate plane. So this one actually would be really graphed easily with the intercepts. And the reason why is it's in standard form. So if x were a 0, it'd be a 0 there. And so 2y equals 2, divide both sides by 2, and 2 divided by 2 would be 1. Y would be greater than 1. And then I would just need to solve for the other side, making the y be the 0. If y were 0, we'd have a negative x is greater than 2, divide both sides by a negative 1, and x is less than negative 2. Remember, you reverse the direction of the inequality. Now, this is an easy and quick way to graph. However, most students seem to be more familiar with the slope-intercept form. So I just wanted to remind you guys that there's this thing out there called the intercepts that you can use. Especially if it's in standard form, it seems to be set up for it. But let's do it the way where most of us are familiar, and that's solving for y. So let's do that real quick. I'll add an x to both sides of the equation. And then you would have 2y is greater than x plus 2. We'll divide both sides by 2. Oops, kind of going on top of my intercepts there. These cancel out, and you end up with y being greater than a 1 over 2x plus, and then 2 goes into itself one time. So to graph this, it'd be the same thing as an equal sign initially, right? So our m and our b is what we need to locate. So our m is 1 over 2, meaning we'll rise 1 and run 2. And our b, well, it's a 1. So we'll start at 1, and then we'll rise 1 and run 2. Rise 1 and run 2. We can really do this all day. Okay, remember you can always reverse it. Go down 1 and go 2 the other way. As long as you reverse in both directions, it works. All right, let's draw our line here. There we go. Okay, and I did this correctly because the inequality is greater than, meaning, oh no, I did it incorrectly. It should have been a jagged line. So I'll have to fix that real quick. Because the inequality is greater than, it's not greater than or equal to, so the line should be jagged. All right. So let's look at the second part to this. It says graph this in a coordinate plane, and we did. Now what we need is a test point. So let's do a test point real quick. A good test point to choose is 0, 0. It makes the math really simple. So I'll test point 0, 0. Now remember, inequalities and equations are very similar. They just have a few differences. One is the jagged line. That's one of the differences. Another difference would be this idea of a test point. You have to do a test point to determine what side to shade. So step 2 is test a point that's not on the boundary line to determine whether it's a solution of the inequality. You can choose any numbers. I like to choose the origin, 0, 0. It just keeps the math so simple. It doesn't look like the origin's on the boundary line. It's pretty close, though, but it doesn't look like it's quite on it. So I'm going to try 0, 0 here. So I'll substitute a 0 for the x and the y. So instead of this y here, I'm going to write a 0. I'm going to read down the is greater than. Half of x would be a 0 plus 1. Is 0 greater than, 0 times half is 0, bring down the 1. Is 0 greater than 1? Well, actually, that's not true. This test point is false. So if this test point, which is on this side of the boundary line, is false, that means this whole side of the boundary line is not true. And so we would shade the top part. And everything on the top part of this equation is the true point. Okay. If I were to have used the intercepts, you don't have to take notes on this part right here, as long as you have all this. But if I were to have used the intercepts, x is 0, y is 1, and then x is -2, y is 0, I mean, I would still, well, it's kind of, doesn't give me a lot to draw the lines with, does it? But I can still do my boundary point. You can choose anything. You don't have to choose 0, 0. I could have chose, I could have chose 1 and 8 to be my boundary point. And if I did, I would just substitute the 1 and 8 into the equation here. So it would be 8 is greater than half times 1 plus 1. Is 8 greater than 1.5? Yeah, it is. And so, since it's true, this that 1 and 8, you would shade in the whole top side because it's true on the top side. All right. It is your turn to try this, so go ahead and give it a shot. All right, I saw a word problem I want to try with you. I think it'd be fun to do. And it says you can spend at most $10 on grapes and apples for a fruit salad. And then it tells you that grapes cost $2.50 per pound and apples cost $1 per pound. And to write and graph an inequality that represents the amount of grapes and apples. So we're dealing with two things. We're dealing with grapes and we're dealing with apples. So we know we're dealing with two things that are kind of unknown. So we can call the grapes like X, and we can call the apples Y. And it says at most. At most is an inequality. It's like a big key. This is an inequality. And so we know that at most means is less than or equal to. So let's go ahead and work this out. You can spend at most, we know we have it is less than or equal to, $10 on grapes. So $10 times the amount of grapes. And apples. So apples, I'm sorry. I did that wrong. You can spend at most $10. So at most would be the $10 at the end here. But you have grapes and you have apples for your fruit salad. The grapes cost $2.50 a pound. So the grapes are $2.50. And the apples cost $1 a pound. Now, if I were to multiply a 1 times y, it would just be y. And it's going to be less than or equal to 10. Ignore this right now. So what I would do in this case, I would solve for y. I would do a negative x 250 to both sides. And y would be less than or equal to. Now remember, we write the one with the x first. So negative, and I'm going to actually switch the order here. 250x plus 10. And now you have your m and you have your b, and you could fairly easily graph this one now. Let's see if I can do it real quick. Yeah, let me just take one of these. So if I were to graph it on a coordinate plane, y equals negative 250. I could write 0.25. You don't need the 0 after. X plus 10. My m would be 250 and my b would be 10, so we go up 10. And then negative 250 means 2.5 as I go down 2 and over a half. I'm sorry, go down 2.5 and over 1. Go down 2.5 and over, and then draw your lines.